Hi everyone, welcome to our video lesson on rewriting quadratics from standard form into vertex form by completing the square. Go ahead and grab your notebooks, pause this video, and write down everything I have in my notebook so far to get you started. So what you guys can see is that we're going to be using something pretty familiar. Completing the square is one of the techniques that we used when we were solving quadratics a couple of units ago. But now we're going to be taking something that is in standard form, ax squared plus bx plus c, and we're going to use very similar steps to transform it into the vertex form that we were talking about in class today. Vertex form is very helpful if you're graphing a quadratic super quickly, or if you're trying to describe transformations when you compare your quadratic to the parent function y equals x squared. So over here on the right hand side, like I said, these will look really familiar because they are almost identical to the steps we used when we were solving quadratics. So we would move the constant to the other side, separating the variables from the constants, add a blank space on both sides, and fill with our formula b divided by 2 squared. Simplify one side, factor the other side, but now instead of solving for x by taking square roots, we're just going to have to isolate the f of x or y variable in any case. And for a lot of you guys, this is going to seem so much easier because those last three steps were the most complicated when it came to solving for x. So let's go ahead and see how this works in action. All right, so I have my example, f of x equals x squared plus 8x minus 15. I'm going to follow step number 1 and move the constant to the other side. Now we've got this f of x on the left-hand side, and it is not a like term with the positive 15. So I'm going to go ahead and write them both down next to each other without the ability to combine them at all. All right, now I'm going to add a blank space on both sides. So f of x plus 15 plus blank equal to x squared plus 8x plus blank. And very similar to solving by completing the square, we're going to go ahead and take this b value, which is the 8. I'm going to bring it over to the side. 8 divided by 2 squared is what our formula looks like when I fill in with that number. 8 divided by 2 is 4. 4 squared is 16, so I get to fill in both sides of my equation with the number 16. All right, up to step number 3, simplify and factor. So on the left-hand side, we've just generated two like terms, 15 and 16, which I'm going to go ahead and combine to positive 31. And on the right-hand side, we've built a perfect square trinomial. And if you remember back to our lesson on completing the square to solve, a perfect square trinomial is one that factors into two identical factors. It's a simple trinomial. It has a 1 in front of x squared. So if you ask yourself, what multiplies to 16 that adds to positive 8, you're going to be thinking of the same number twice, in this case positive 4 and positive 4. So my factors on the right-hand side would look like x plus 4 times x plus 4, but we always said that why write something times itself when we can rewrite that as x plus 4 squared. And it is no coincidence that we've already seen that positive 4 when we did 8 divided by 2 in our b over 2 squared. And some of you guys remember this trick from when we solved. This number on the inside is always half of the b term that was in our perfect square trinomial. So if this is a positive 8, this is a positive 4. If this was a negative 16, this would be a negative 8, etc. All right, the last step, isolate f of x. We're just going to go ahead and subtract the 31 back to where it started, or back to where the 15 started. 31 wasn't really there before. And I have f of x equal to x plus 4 squared minus 31. And that's it. That's vertex form of my original quadratic, which tells me right away that the vertex is the point negative 4 comma negative 31, opposite of the inside, keep what's on the end. And it can also tell me that the graph of this quadratic is going to look different from the parent function because it's going to shift to the left 4 and down 31 spots. All right, so let's see one more example a little bit quicker. Okay, feel free to pause the video and try this one out on your own, but I will have some independent practice questions on the end if you want to follow with me for the next two examples. All right, so we're going to go ahead and move the constant to the other side. So this will say f of x minus 3 equal to x squared minus 6x. I'm going to go ahead and put the blank space on both sides to make that perfect square trinomial on the right. The negative 6 is my b term here, so if I do negative 6 divided by 2 squared, remember if you divide by 2 you get negative 3, but negative 3 times itself is positive 9. That's why I always put the plus sign and then the blank space. We're always going to be adding to our trinomial here. So this is going to say f of x plus 6 is equal to x minus 3 squared. Wow, how did I do that so quickly? All right, well, what two numbers multiply to 9 that add to negative 6? Negative 3 and negative 3. Shortcut, what's half of negative 6? Throw it in the parentheses and then put a squared on the outside. Minus that 6 back to where we first had that constant, and you magically have your quadratic in vertex form. Quick, simple, easy. Once you get the hang of it, you guys will get these questions done, I would say, under a minute or less. All right, I'm just going to do one more example. I'll squeeze it in over here because I do want you guys to be careful if we have a quadratic with an odd b term. Okay, it's not impossible to put it into vertex form. It's going to be a little bit trickier, and we have to be careful because we're using the formula b divided by 2 squared, but it's the same step. So let's go through this example and I'll show you guys exactly what I mean. So we're going to subtract the 10, same as we always did, and I'm going to go ahead and add our blank space in the same line. Kind of save a little space in my notebook here. And now when I take the positive 3 and I cut it in half, we get 1.5. Okay, 1.5 squared is going to be 1.25. Just kidding, I meant 2.25. I don't know why I said 1.15. So I'm going to fill in both sides with 2.25, okay, which for some people gets a little scary, but don't freak out just yet. All right, I'm going to combine on the left side. Let's do negative 10 plus 2.25, that would be negative 7.75. Correct me if I'm wrong. And then on the right hand side, it's really helpful to have that shortcut, because instead of asking myself what multiplies to 2.25 and adds to 3, I'm just going to go ahead and take half of 3, which is 1.5, and I'm going to put that in the parentheses square. So if I go ahead and add the 7.75 back to the other side, f of x is equal to x plus 1.5 squared plus 7.7. Oh, running out of ink. There we go. 7.5. Okay, so in this case, my vertex would be the point negative 1.5 comma 7.75, which is a number that would not show up on my table in my calculator, and it would be pretty hard to read on my graph. So this is a great reason why knowing how to do these processes can help us answer any question. So now what I've done is I've written down 4 practice problems for you guys to try on your own and see if you got the hang of this. What I'm going to do is I'm going to skip ahead, and you'll be able to see the answers completely done, the whole question finished, and then that way individually you guys can figure out if you got the right answers or if there are certain questions that you need to check. Remember, you should not be skipping ahead and just copying everything I have in my video. That's not helping you learn. And especially now when you're doing this lesson on your own, try it out. No one's going to tell you if you're right or wrong besides yourself. So go ahead and see if you got the hang of it. All right, now that took me about 3 minutes to get all 4 of those done, but I've had plenty of practice. So let's see how you did. Okay, be careful in question number 3. When you take half of 2, you get 1, and 1 squared is still 1, so there should be a 1 on both sides. And maybe you got a little confused with number 4, but if there's no constant to add, that just means I get to skip step number 1. So I already had my constant over on the other side as a 0, if you want to think of it that way. And then I just added half of b squared to both sides and completed the process that way. Okay, remember that having it in this formation helps me to determine what the vertex is going to be just by reading. For example, the vertex here would be -1, 4. And then it also tells me some transformations that we might have moving left, right, up, or down. Okay, bring in any questions or confusion that you have tomorrow, and we'll practice and move on. Have a great day, everyone.